Hello, in today's video we're going to talk about U-substitution. So U-substitution basically is help you to get antiderivative of the chain rule. In another word, that means unwinding the chain rule. So let's review what is chain rule. Chain rule is if you have a embedding function like f of g of x, I'm trying to get the derivative of this function. The way that we do it is we take the derivative for the outside function and multiply the derivative of the inside function. So U-substitution is you doing the antiderivative of these two functions, the inside and outside. So here's the example. I want to get the antiderivative or the integral of 4 minus x squared d of x. The first step is you need to pick the u. What will be the u? Well, usually we'll put an embedded function. And which one do you think look like embedded function? Well, would be this one, right? So I will let u equals to 4 minus x squared. And then the next step is I take the derivative of u. So on the right side, I have negative 2x. All right, now you can treat this derivative as a fraction, but it's not a fraction, but you can treat it as a fraction. And next, try to solve for dx. Well, dx is in the bottom, so that means when I solve it, I should have du over negative 2x. Okay, so now next step is you want to substitute dx equals to du minus 2x in here, because that's your dx. And now you also want to substitute u equals to 4 minus x squared in here. So let's take a look. What does our function look like? I will have square root of u. Dx now is equals to du over negative 2x. Now our x got cancelled out. That means you pick the right function to choose it as in u. So now I got 1 over square root of u and then times negative 2. Since it's a constant, I can put the negative 2 out, the negative 1 over 2 out, and du. So in order to easier for us to get the derivative, we can rewrite this into exponential form. So I have a u to the negative 1/2 at du. Now, getting the derivative, antiderivative of u to the negative 1/2, we did this before. We need to add 1 to the function, which gives you 1/2, and then multiply its reciprocal. Don't forget to plus the constant c. So I have a negative u to the 1/2. Now, 1/2 means square root of u. Now we can substitute the function back. Remember, our u is equals to 4 minus x squared. Now we substitute the u back. Oh, don't forget to plus c. 4 minus x squared. Okay, so here's the result. So if you're not sure that, hey, if I got this right, one way to do it is you take the derivative of your answer. If you get back to where we begin with, that means you did the right things. So now let's take derivative of this one. Well, I want to take derivative of negative 4 minus x squared. So the negative, I can just take it outside. We don't need to worry about that. Now we need to use the chain rule. we can take the derivative of the square, whatever under the square root first. Let's pull out the negative sign outside. So the derivative of whatever inside is going to be 1/2. So we have a negative 1/2, and here we multiply 1/2. And then multiply everything inside the derivative, because that's the inside function that we're trying to take. So I have a negative x 2x. Alright, so now let's simplify and multiply a little bit. So negative, negative, they cancel, and 1/2 and 2, they end up to have 1. So your final answer should be x times 4 minus x squared to the negative 1/2. If we write this into a fraction form, we will get 4 minus x squared square root. So now this is the original function. So that means we did the antiderivative correct. Okay. Here is a second example. We want to integrate e to the x plus 15 to the third power. So for this one, I want to take u, the embedding function, u equals to ex plus 15. So I can rewrite the function as e to the x u to the third dx. I substitute this first. Alright, so the next step is I want to get what's the integration of at du at x. Well, e to the x, I got e to the x. And now I want to solve for dx. So ds is equal to du over e to the x. Now we can substitute this for our dx. So I got e to the x, u to the cubed, and then du over e to the x. Now e to the x, they can cross cancel, so your answer end up to be u to the negative 3 power at du. Now we can do the antiderivative, which gives you 1/2 u to the negative 2, and then plus the constant c. Don't forget to substitute u equals to ex plus 5 into the original function. So I got negative 1/2 ex plus 5 to the negative 2 plus c. Again, one way to check to see if this is the correct answer is you want to check. So now let's get the derivative of negative 1/2 e to the x plus 5 to the negative 2 power plus c. Well, I can put the negative 1/2 out, trying to just get the derivative of this function. And then constant, if you get the derivative of constant, it's going to equals to 0. So we don't need to worry about that. So this one, we need to apply the chain rule. For the chain rule is you want to get the derivative of whatever inside the parentheses to the negative 2 power of derivative, which is negative 2 times e to the x plus 5, negative 2 minus 1 gives you negative 3, and multiply the derivative of the inside function, which is es plus 5. So I have negative 2 and 2, they cross cancel. And then on this side, I have e to the x plus 5 to the negative 3 power, which is 1 over 3 times the derivative of inside the parentheses, which is e to the x. So your answer is e to the x plus 5 to the third, which is the original function. All right, a third example, which is derivative of x squared over x third plus 5 dx. Now this one, we want to let u equals to x cubed plus 5. So our du over dx equals to 3x squared. Okay, so now we still need to treat this as a fraction to solve for dx. So our dx is equals to du over 3x squared. Now we can substitute things back, such as I want to substitute u for x cubed plus 5, and then I can substitute dx with du over x to the cube. Oh, I'm sorry, 3x times square. Simplify, I have 1/3, pull the coefficient out, 1 over u at du. So the antiderivative of 1 over u, this is the special case, which is equal to the natural log, not -1. Because when we take in the natural log for the special case, we take in, there's two special cases that we learn, right? The derivative of a natural log is equal to 1 over x. So that means the antiderivative of 1 over x should equals to the natural log. The other special case is e to the x, take a derivative, is equals to e to the x. So that means your antiderivative at e to the x should equals to e to the x. So in here I have a 1/3 ln of u plus c, and our u is equal to s cubed plus 3 plus 5. So that means for the antiderivative, this is s cubed plus 5 plus c. Well, we can check our answer by doing the derivative back, see if we can get back to the original answer. So I have a 1/3 times natural log x to the cube plus 5, and I want to get the derivative of it. The first step is I can pull the 1/3 out, so I have a natural log s cubed plus 5 derivative. So apply the chain rule, so I will have 1 over x cubed plus 5, and then multiply x cubed plus 5 the derivative. So simplify, I have 1 over s cubed plus 5, and then the derivative of whatever inside the parentheses is equals to 3x squared. After simplify, I have x squared over x cubed plus 5. Oops, sorry. Which is our original function. Okay, so this is for indefinite integral, which means you need to plus a constant at the end. So what about for the defined one? So for the defined one, such as I want to integrate from 2 to 10 ln of x over x to the 6th power at dx. So for this one, we do the same thing by using the U-substitution. U is equal to ln of x. So that means if I get the derivative of u, I will have 1 over x. So that means my dx equals to, when I solve in it, I have x times du. Oh, I'm sorry. These parentheses should be in here, just on the top. So the 6th power is just to the numerator. All right, so next step is I substitute u for the ln x, and the dx is equal to x times du into the function. I have a 10, 2, and then I got u to the 6th power over x times du. Now, when we simplify it, cross cancel these two, so I end up to have 10 from 2 to 10 integrating u to the 6th power at du. So this one should equals to 1 over 7 u to the 7th from 2 to 10. Now, we substitute u back. So for 1 over 7, u is equals to ln of x from 2 to 10. So that means when you calculate that, this should equal to 1 over 7 multiply ln of 10 subtract ln of 2. So that would be the answer. Okay, so that's it for the U substitution. If you have any questions, please let me know. See you next time.